Hello viewers, welcome to CEC lectures. Myself Dr. Preeti Jagwani. I am from Department of Computer Science, Aryabhat College, University of Delhi. So presently we are going through our topic of multi-threading, and we have covered in the last lecture that was what is the difference between multitasking and multi-threading and how a thread is actually different from a process. And now what we are going to cover in this lecture is all about the various states of thread, or we can say a complete life cycle of the thread. With that we are going to look into with the help of various explanations and also with the help of a figure. So when we talk about a thread, it always exists in any one of the states. What are these states? These states are actually 5 states. One is new, another one is active, third one is blocked or waiting, fourth one is timed waiting, and fifth one is the terminated. Now a thread will always exist in any one of these states. Now let us dive into the explanation or details of these states. So when we talk about new, the simplest, or we can say it's a self-explanatory kind of thing. That means whenever a new thread is created, it is always in the state new, and for a thread which is in the new state, the code has not been run yet. That means we haven't executed any of the code corresponding to that particular thread, and simply we can say this thread has not begun its execution. It is just kind of, we can say it is just got the birth, or it is just being kind of created. The second state or the second stage is about being kind of, we can say, start being getting active, and that is the name of the state is active. When a thread invokes its start method, so each and every thread is having a start method. Let us take it as of now till we get into the programming nuances of this multi-threading. Now when the start method of the thread is being invoked, that means that thread has been moved from the new state to the active state. So new is just when your thread has just been created, not executed yet, and when it will start execution, that means the thread invokes the start method. So the active state contains 2 states within it. One is runnable and another one is running. So the thread is being just created, a new thread. Start method is being kind of run or executed. Now it comes into the active state. Now this active state is also kind of, we can say, comprises of 2 situations. One is runnable and another one is running. So when we say runnable, runnable means a thread is ready to run and is then moved to the runnable state. So when a thread is in the runnable state, that means it is kind of, we can say, ready to run. In a runnable state, this thread can be as I told you, may be ready to run at any given instant of time, or it may be running. Why I am saying this? Now this seems this could create confusion to some of the viewers. Now let me explain it here. When we say that in the runnable state, the thread may be running or may be ready to run at any given instance of time, this is what actually kind of we can say duty of the thread scheduler to provide the thread the time to run. That means moving the thread to the running state. So imagine it this like this, that active state is there, then within the active we have runnable and running. So runnable is actually ready to run, and when it started running, this will we can say switch from runnable to the running state. So runnable is kind of geared up or ready to run, and a programming or a program which is implementing multi-threading requires a fixed slice of time to be given to each individual, a fixed size of execution time I am talking about, to be given to each individual thread. Now here who is going to decide that which particular thread's turn is now, and which thread is going to get that fixed slice of time, whose turn is this. So this is actually kind of, we can say, is going to be decided by the thread scheduler. That means it is the responsibility of the thread scheduler to provide the thread time to run, that is moving from its runnable to the running state. Now here each and every thread will run for a very short span of time. It is what that allocated time slice is, and now after that the thread will voluntarily gives up the CPU to the other thread, and this is having its, this statement of having its own connection to this to the term that I have used in the previous lecture, that these threads are cooperative. So cooperative in the sense that there are threads, or there can be a kind of a policy decision that these threads are voluntarily giving up the CPU to the other thread, so that the other threads can also run their short span of time, or their slice of time, we can say. So whenever such a scenario occurs, all those threads that are willing to run, waiting for their turn to run, they lie in the runnable state, and one that is kind of getting executed presently is in the running state. So it is between the runnable state and the running state, these threads, we can say, they are switching in, and in the runnable state there is a queue where all these threads are lying. So the thread scheduler will take one particular thread from the queue depending upon the policy, and then that thread will be jumped from runnable to running state. That means that thread has now got the CPU slice, CPU's time slice. So when the thread gets the CPU, it moves from runnable to the running state, and here is the next part of the active stage, which is running. So generally the most common change in the state of thread is from runnable to running, and it could be vice versa, it could be again back from running to runnable, because this is, as I have told you, this is a queue that threads can voluntarily also give up the CPU for other threads to get executed or to get run on. So this is kind of switching between, or the most common switching between these two threads state which happen is that is from running to runnable, and the vice versa as well. So we have seen the new which is kind of the thread has just been created, then active, then within the active it could be running or it could be runnable. Now the third stage which is coming up here is about blocked or waiting. Now, so whenever there is a thread which is inactive for a span of time, but it is not permanently inactive, then either the thread is in the blocked state or is in the waiting state. Now, this is very different from the runnable state. So, thread is inactive for a kind of we can say considerable span of time, but not permanently. Then either the thread will be considered in the block state, or it could be in the waiting state. Now, why a thread comes into the block state or blocked state, or why a thread comes into the waiting state? So, let us try to understand this with the help of an example. So, let us say we have a thread 1 which may want to print some data onto the printer, and at the same time another thread, let us say thread 2 is using the printer to print some data. Now, printer is a device which cannot be kind of simultaneously can be used by two devices. So, that means thread 1 has to wait for the thread B to use the printer. So, that means we can say this thread A is now in the blocked state. Now, a thread which is actually in the blocked state is unable to perform any execution, and because it is not allowed to have any execution, it will never consume any cycle of the central processing unit or CPU we can say. So, thread in the blocked state is not going to consume any cycle, is not going to utilize any cycle of CPU. So, one can say that a thread 1 or even any of the thread which remains idle until the thread scheduler reactivates the thread A or thread 1 which is in the waiting or blocked state. So, from going from runnable to running state is also the job of the thread scheduler. Similarly, when we talk about going from or switching from waiting or blocked state to the runnable state, that is also the job of the thread scheduler. So, one thread which is remaining idle and it will remain idle till the thread scheduler reactivates it, and after reactivating it, that thread is going to be put on into is going to be put on to the runnable state from waiting or blocked states. Now, if there are there can be multiple threads. So, if there are lot of threads which are in the waiting or the blocked state, then it will become responsibility of the thread scheduler to determine which thread to choose and which one to reject, and which thread is going to be going to get the opportunity to run. So, the selection for getting the CPU time slice or selection for coming into the runnable state is actually lies in the within the purview of your thread scheduler. Then that was blocked or waiting state, that means a particular thread is waiting for a resource for a considerable amount of time. Now, when we say another state, so we have seen new and then we have seen active. Within active we have seen runnable, we have seen running, then we have also seen blocked or waiting. The fourth state here is the timed waiting. Timed waiting is actually, so for example, one particular thread is waiting and it keeps on waiting because of some one or the other reason. It may lead to starvation. So, for example, a thread let us say A has entered into the critical section of the code and is not willing to leave the critical section. Although in other situations, if it would not have been a situation of the critical section, the threads are voluntarily giving the CPU to other threads because of being cooperative. Here a thread A has entered into the critical section of the code and now it is not willing to leave the critical section. In such a scenario, what this another thread which is named as thread 2 will do, it can't do anything despite in spite of waiting forever, and this will lead to the starvation. That means now your thread B is actually starving to get your CPU slice time. So, in order to avoid now this is a scenario which is kind of, we can say, non-desirable or it is an unpleasant scenario. So, in order to avoid all these non-desirable scenario, we have a timed waiting state given to thread B. So, that means the thread lies in the waiting state for a specific span of time and not forever. So, that means it will not go into the starvation. So, for example, let us say we have set a particular span of time, let us say 10 nanoseconds or something of that sort, that a thread who is waiting for one particular resource will be in. So, thread B will be in the waiting state only for those particular time slides, and that is nothing but known as a timed waiting. Now, how are we going to ensure that, or what is the method through which this timed waiting is going to be achieved in a program? So, a real example of this timed waiting is when we invoke a sleep method on a particular thread. So, when we say sleep method, this method will put the thread into a timed wait state, because with this sleep method we need to give the time slice that for which particular time this thread is going to be sleep, or this thread is going to be kind of in a non-active situation, or this thread is going to wait, we can say. So that the sleep method puts the thread in the in a wait state, but that too kind of we can say controlled by a particular time span. And after that time runs out, the thread automatically wakes up and starts its execution from where it has left earlier. So this is what it is. When we want to put a particular thread into a timed waiting state, we are going to run sleep method on that thread, and for the time span for which we have made the thread sleeping, after that time span runs out, the thread wakes up and starts its execution from which it has left earlier. So we have seen out of 5 we have seen 4 stages of 4 states of thread or 4 stages of thread life cycle. The 5th one is the terminated. Terminated state, as the name indicates, a thread reaches the termination state maybe because it has finished the job, then obviously it is going to execute it is going to exit, or it is going to terminate normally. So if a thread has kind of we can say got into the termination state, that means it is not going to be now it is not going to run anymore, it has finished its job, and that is why it is going to be exit, or that is why it is going to exit or terminate very normally. Another situation when the thread can get terminated is because of some abnormal situations or some abnormal termination. What kind of abnormal termination I am talking about? So it occurs when some unusual events such as an unhandled exception, the exception which we have not handled, or maybe a segmentation fault, something of that occurs which is kind of out of control. That situation also causes a thread to get into an abnormal termination, and a terminated thread means the thread is no more in the system. That means now the thread is dead, and there is no way that it can be kind of activated, or it can be reactivated after termination or after killing a dead thread. So in other words, we can say when a thread is dead, there is no way one can respawn, that is make it active after killing that dead thread. So we have seen 5 stages of 5 thread states. One is new, another one is active. Within the active we have seen runnable and running. Then we have our blocked or waiting, then we have timed waiting or bounded waiting, we can say, and apart from that we have the terminated thing. Now what is the we can say connection between these states? Now let us try to explore this figure within the reference of whatever concept we have understood about the life cycle of a thread. So it started from the new, that means it is just being created. Now after the new, it is going to the next state, which is the active state. So in active state we have 2 situations, one is the runnable, another one is running, and the arrows between the runnable and the running states are going to show a kind of we can say switching from runnable to running and vice versa. So runnable means actually it is waiting for the CPU, but ready in every sense, and running, when we talk about, that means it has already kind of it has got the CPU, that means it is kind of getting executed. Then on the left hand side, if we can see, we have a blocked, that means it could be acquiring a lock in the sense you can see here that we have seen the concept of locks in the critical section in our operating system in our operating system lectures. So it has acquired a lock, that means it is being blocked, and then when this lock is actually kind of released, it is coming back to the active state, to the runnable within the active state. Then it could be, you know, waiting for some notification to arrive. Then then your a thread is in the waiting state, so it is waiting for the notification, and that when that notification has arrived, when that notification has been acquired, it is again coming back to the, you know, runnable state. Timed waiting, as I have told you that, you know, this thread is actually sleeping. That means it is waiting for a timeout notification whenever that particular time span gets over for which we have ordered this thread to get sleep. When this timeout notification is occurred, it will again come back to the active state. So, from new it can go to the active state. Within the active state, it will switch between runnable and running very frequently. Then from this active state, it could go back, it could go to blocked and come back, similarly to the waiting state, and it could come back. Then from active state, it can go into the timed waiting state, and it will come back unless it is, you know, kind of finally terminated, or it is declared as a, you know, kind of dead thread. That means it is kind of the run method is kind of we can say we are exiting, or the control is exiting from the run method. That means the thread is going to be, you know, terminated. So, new, active, blocked or waiting, timed waiting, and finally the terminated. So, when we say this whole scenario in a nutshell, we can say a thread can be running, it can be ready to run as soon as it gets a CPU time, that is runnable. A running thread can be suspended, which temporarily halts its activity coming from running to runnable, and a suspended thread can be resumed, allowing it to pick up where it left off. Then a thread can be blocked when waiting for a particular resource, or at any time a thread can be terminated, which halts its execution immediately, and once terminated a thread cannot be resumed. So, once kills, it's like when a thread is being terminated or killed, its life cycles comes to an end. Now, after understanding this whole situation of the life cycles of the thread or the states of the thread, we can say we have, you know, stated this fact many times that the thread scheduler is one which is responsible for picking up the threads and, you know, giving it the CPU, or, you know, changing the state. So, there must be, you know, some policy, you know, decision, there must be some policies according to which this thread scheduler is going to pick up the thread. So, this is actually this lends up with you know, kind of term which is known as thread priorities. So, Java assigns each thread a priority that determine how a thread should be treated with respect to others. So, when I am saying about with respect to others, there is, you know, kind of no meaning of priority which is you know, kind of an absolute value which is not with respect to others. So, that means what I am talking here is we have some integers that specify the relative priority of one thread to another. An absolute value priority is, as an absolute value, the priority is meaningless. A higher priority thread does not run any faster than a lower priority thread if it is the only thread running. There can be a higher priority and a lower priority only if there are at least two threads running, and this thread priority is actually, you know, nothing but the absolute integers. And instead threads priority is used to decide when to switch from one running thread to the next. And this is basically in operating systems also we call it as the context switch. Now, what could be the rules which are governing the context switch? So, that means this thread scheduler which I was talking about, how that thread scheduler is going to take you know, a decision about the changing the states of these threads, or how this context switch is going to happen. So, there can be two situations. One is a thread can voluntarily relinquishes the control, which is done by explicitly yielding the sleeping or blocking and pending input output. In this scenario, all other threads which are examined, and the highest priority thread which is ready to run is given the CPU. The one which is running has left the control of the CPU. Whatever there are, whichever threads are available, the highest priority thread among them will be given the CPU. Also, a thread which is of lower priority can be preempted by a higher priority thread. So, a lower priority thread, if it does not yield the processor, it will simply be preempted. So, there can be two situations: either it is going to relinquishes the control voluntarily, or if it is a lower priority thread, it will be simply preempted as soon as a higher priority thread wants to run. So, this is also this could be kind of a preemptive multi-threading, we can say. So, here in this lecture we have understood all the 5 stages, 5 states of a thread, and we have also tried to understand the whole concept with the help of a figure, and we have also looked into the priorities of threads and how these context switch between from one thread to another thread will be governed. Here is a list of references which is being used for the preparation of lecture. Hope you have enjoyed one. I will see you in the next lecture. Till then, take care. Goodbye.